Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Welcome to Inequalities. When working with inequalities, we are talking about when we have symbols like this, or this. And I tell my students, anytime you see an inequality symbol, think of it like a turn signal. Turn signal means shading. So if we're on a number line, shading is just left or right. If we're on an actual coordinate plane, we have up and down. So the other thing we can think about is a comparison to zero. Left is zero, right is zero, above zero, below zero. If you are ever questioning it, the way to solve these is make it your equation and your symbol, could be one of the other four, compared to zero. And if you were to graph it, less than would mean below zero, whereas greater than would mean above zero. So you can get a visual of that graph. However, depending on what variables they're talking about, if they're asking you to solve, if they're talking to you to use to solve about x, then we're going to be utilizing just the information about the x's for when it's below zero, or just the information about the x's for when it's above zero. So let me explain to you what I mean by that. Let's look at negative 4x plus 7 is less than or equal to 19. So if I were to solve this by graphing, I'm going to come in here and I'm going to move everything to one side, and I don't want to make any errors myself, so I'm going to type it in exactly as it's written and then just subtract the 19 over. So now it's compared to 0. Okay, and I'm going to graph. Now less than 0 means below 0. So we're below 0 here. So wherever it's touching the x-axis and to the right is where we are below 0. So let me calculate that. Where is that 0? To the left and to the right. So negative 3 and bigger is what our graph is showing us. So this side of our graph, the graph has gone below the x-axis. Why below? Because we're looking at less than. Okay, so negative 3 and bigger is what we're talking about. So that would be an interval starting at 0 and continuing to infinity. And if you don't understand interval notation, go back and watch one of my videos on that. Not 0, it crossed at negative 3. I had 0 on the brain. So any x's between negative and 3 and infinity will make this true. Well, let's check. 12. Negative 4 times 12 plus 7. Absolutely, that's smaller than or equal to 19. So yes, we are working here. So why is this working out that way? So if this were an equal sign, the way we would solve it is to subtract 7 to both sides, and we'd find out that negative 4x is smaller than or equal to 12. Okay, this is a less than. Why did that go bigger? Okay. Well, we have to divide by negative 4 to both sides. And when you divide by a negative, you flip your inequality. So 12 divided by negative 4 is negative 3. Why is that? Why do we flip our inequality? Well, let's just do a little side note. Do you agree that negative 3 is smaller than 5? Yeah, being in debt is having less money than having money. If we were to multiply both sides by negative 2, now we have 6, negative 10. Is 6 still smaller than negative 10? No, it's greater than. Okay, let's look at another example. What if I did negative 3 and negative 5? Now negative 3 is bigger than negative 5, right? Divide both sides by negative 1. Is 3 bigger than 5? No, it's smaller than 5. And so if you think about the number line on the positive side, starting at 0, It goes 1, 2, 3, 4, 5, right? 5 is to the right of 1. But if we look at our negatives, -4 is to the left of -2. So it's like the numbers are backwards, right? So that's why when we multiply or divide an inequality, because of an inequality and the fact that we divided in this case by a negative, it's not because the negative was here. Okay, so for example, if I had 8x is less than 24, -24, I'm going to divide both sides by 8. Since that 8 is positive, I'm not changing the sign. Or you can think of it like, this was negative, now it's positive. This was positive, now it's negative. So if you change these two signs, shouldn't you change that sign? However, you need to memorize it that when you multiply or divide by a negative coefficient, you must flip your inequality. I don't care whether it's less than to a greater than or greater than to less than. But that kind of gives you some background as to why. So don't forget that that is a thing. So let's just check. 9x plus 4 is less than 3x. Okay, there's two ways to solve this. Okay, I could subtract the 3x, subtract the 4, and then divide by a positive 6. -4 over 6 reduces to -2 over 3. So I could do it that way. Here, I did not flip the inequality sign because 6 was positive. Okay. The other option I could have done was subtracted 9x and then divide by -6. So -2/3 flip. And some of you might say, well, what I have written in blue and what I have written in brown are different. The signs are going different ways. And the answer to that is no. This reads x is smaller than -2/3. This reads -2/3 is bigger than x. Isn't that saying the same thing? It is. However, this one gives us an idea of which way our arrow is going to go. Our arrow is going to go left of -2/3 because we need to be x needs to be smaller than -2/3. And we can't include. So let's see if graphing would have gotten us that. Y equals 9x plus 4 minus 3x. And we're still looking for less than 0. Less than 0 was on this side. And it does look to be at -2/3 where it hits. Absolutely. So our answer is -infinity, ending at -2/3, not included. Now these are both linear and we can do them without the graphing. However, if it's nonlinear, you want to compare to 0. Use factoring to solve when you can. And then use test points. I actually do not use test points. A lot of books will tell you to use test points. We have graphing calculators. We know graphing behavior. So I don't necessarily always do test points, but I will talk about the test points. So x squared is less than or equal to 5x minus 6. Let's do greater than. I did less than on the last two problems. Let's do greater than. We'll just do strictly greater than. And we'll get that to focus. Okay. So So in this problem, we're going to look at x squared is greater than 5x minus 6. So it is quadratic, so I'm going to move everything to one side. X squared minus 5x plus 6. And now we're looking at greater than 0. Now we happen to know that parabolas with a lead coefficient that is positive 1 is going to make a happy face, right? So let's see if it does cross the x-axis. We can happen to solve this one by factoring. X minus 2 times x minus 3. So since it factors, it does cross the x-axis twice. Okay, so I didn't actually use test points. I used what I happen to know about a parabola. Test points means you just pick random points and test them to see whether they make it true or false after you find out where it hit 0. So we're going to learn that this is going to cross at x equals 2 because of the quadratics and x equals 3. Could you have done the quadratic formula? Absolutely. So if you were doing test points, I would do a test point of like 0, 2.5, and 5. Something from the first section. So see, I've split this into 3 sections, the first section, the second section, and the third section. If you had substituted 0 into this, you would have found out you had a positive answer. And since positive is greater than 0, this section is true. If you had utilized like 2.5, you would have found out that you would have gotten a negative answer, which is below 0, which is not true. And if you would put in 5 or even 10 or 20 or whatever, you would have found out that it was a positive or greater than 0 answer, which is true. I just like looking at the graph and going, ooh, it's above, below, above. Greater than 0 is above. So I don't like doing the test points. I just like doing above, below. I like using the shape of the graph. Okay, so we are only supposed to discuss answers that make this true. So we're talking about this section of graph which continues to the left and this section of graph which continues to the right. So in interval notation, this is true for our x between negative infinity and 2, not included, or 3 to infinity. So almost every number out there is going to make this true as long as you don't pick something between 2 and 3. Now, this is okay because it's an or and it can go both ways, right? Had I said x squared is less than or equal to 5x minus 6, then we would have had x squared is less than or equal, x squared minus 5x plus 6 is less than or equal to 0. Now that's just this middle section, right? Between 2 and 3. So that would be comparing it to 0, and to solve the absolute quadratic, we solve by factoring, we're able to show our work. How are we going to show our work for something like this? Again, it's not linear, right? Well, if you have a graphing calculator, you can still graph absolute value. We have to subtract the 2, right? Okay. So I compared it, again, I'm comparing it to 0, right? When I graph it, I have to compare it to 0. And I'm seeing that it's less than 0 in between 3 and 7. But I need to support that algebraically. So the way they really do this is to drop our absolute value signs. Less than symbols, we think and. Greater than symbols, we think or, when it comes to absolute value. We've already solved by graphing. So positive x minus 5 is less than 2. And negative x minus 5 is less than 2. The other thing is I think of as absolute value as a distance from 0. If this is the distance, if this is a I hid a $100 gift card within a 20-foot radius. Now you're going to know that you're in here, and that's a small section. Within or less than 20 feet, right? If I said I hid that gift card greater than 20 foot away, well, now that could be anywhere. It could be across the ocean. So it's very important that we understand like less than is on absolute values is in the center, where greater thans are going to be on the outsides. So there's a visual. Can you double check this with graphing? Absolutely. Do we solve these just like their equal sign? Yes. But remember, to drop the absolute value, you have to do it once as a positive and once as a negative. It kind of looks like a weird frowny face. Was not the intention, but. So there's nothing to do here, so I'm going to add 5. So x is less than 7. Distribute the negative. Subtract 5. Ooh, got to divide by a negative, so I'll flip my inequality. So the one says x is greater than 3, and the other one says x is smaller than 7. And since it's an and, we want both. So that means x is going to be between 3 and 7. And when we look at the graph and we had moved everything to one side, absolutely, it is below 0 between 3 and 7. Also, if you notice, hey, get that back on. 5 is in the middle, and it goes 2 blocks to the right, 2 blocks to the left. So the distance, because absolute value is the distance, between x and 5 is 2. So the distance between your spot and the number 5 is within 2 units. So you have to be within 3 and 7. A fun or not fun, depends on how you are looking at it. If you have the absolute value of some equation is greater than a negative number. Well, when is a positive greater than a negative? It's always, it doesn't matter the equation. But if you have the absolute value of an equation is less than a negative number, well, when is a positive smaller than a negative? This would be the empty set or no solution. So absolute values can be always true. They can be never true. And the thing is, that goes for quadratics as well. So asking them when they're positive or negative. So we have to be very careful with that. Okay, so you might be using real world inequalities. You might be like, no way, but, okay, you're going to rent a car. You have to choose between company A and company B. Okay, company A has a daily rate of $50, whereas company B has a daily rate of $70. Okay, so right now you're probably going, I'm going with company A. They also have a mileage rate of 80 cents, while company B has a mileage rate of 40 cents. When is company B going to be the better bet? Okay, well, let's say we're just going to rent for one day. So company A would be 50 plus, right? Whereas company B would be this. So how many miles would we have to drive for company B to be the better deal? When would it cost us less than company A is what we're asking. When is company B less than company A, making it the better deal? So I'll subtract 0.4m from both sides, and I'll subtract 50 from both sides. So I subtracted, moved all our variables to the left, all of our constants to the right. Now we're going to divide. After 50 miles. So if you're going to rent this car and you're going to drive more than 50 miles, you should choose company B. Just because company A had the better daily rate doesn't mean company A is the best option for you. Now, if you're going to stick around in town and you're only going to go like 20 miles and you just don't want to use an Uber, well, then obviously company A is what you're going to go with. But once you hit 50 miles, company B is the better choice. So inequalities really do appear in our real life. You might do it with a cell phone company or a plan. Maybe you're doing a data plan for your home wireless internet about when data rates are going to slow you down. So make sure that you understand with inequalities, it's easier to check your work by moving everything to one side and comparing to zero. Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.